What if I told you that a single teaspoon of material from a neutron star weighs as much as a mountain? And what if I said that these stars, spinning at mind-boggling speeds, can crush the laws of physics as we know them? Buckle up, because today we're diving into one of the most extreme, weird, and mysterious objects in the universe: neutron stars. Forget everything you think you know about stars. We're not talking about twinkling dots in the night sky, or even giant glowing balls like our sun. Neutron stars are something entirely different, so dense that the entire mass of the sun is compressed into something the size of a city. These stars challenge what we know about the universe and reveal secrets about space that are stranger than science fiction. Today, we're peeling back the layers of neutron stars and showing you why they're more bizarre than you could ever imagine. We think of stars as these stable, long-living powerhouses of light and heat. But neutron stars? They break all the rules. They're born from destruction, the aftermath of a supernova explosion that leaves behind a remnant so dense it warps space and time. They spin at insane speeds, sometimes hundreds of times per second, and they have magnetic fields trillions of times stronger than Earth's. But the real mystery is in their insides, where the laws of physics we rely on seem to completely fall apart. What is a neutron star made of? How can something so small be so powerful? And why do they behave in ways we can barely understand? To understand just how strange neutron stars are, we first need to look at how they're born. It all starts with the death of a massive star. When a star several times bigger than our sun reaches the end of its life, it runs out of fuel. No more hydrogen for nuclear fusion, no more energy pushing outwards to keep the star stable. What happens next is mind-blowing. The core of the star collapses in on itself. Gravity takes over, crushing the core down with such force that electrons and protons are smashed together to form neutrons. This collapse happens so fast that in just a matter of seconds, the star's core, which was once as big as Earth, shrinks to about 10 to 20 kilometers across. That's smaller than most cities, but don't be fooled by its size. This tiny dense object is the beginning of a neutron star. During the collapse, the outer layers of the star are ejected into space in a spectacular explosion called a supernova. The energy released in this explosion can briefly outshine an entire galaxy. But at the heart of this chaos, a new kind of star is born. A neutron star, the densest object in the universe outside of black holes. Alright, let's wrap our heads around this. Imagine taking the entire mass of our sun, which is about 333,000 times the mass of Earth, and compressing it down to something just 20 kilometers in diameter. A neutron star is so dense that just a teaspoon of its material would weigh about 1 billion tons on Earth. That's right, one tiny teaspoon would outweigh some of the largest mountains. But how can this be? Well, the answer lies in the structure of a neutron star. These stars are made almost entirely of neutrons, subatomic particles that are packed together tighter than anything we can imagine. On Earth, atoms are mostly empty space. In a neutron star, that space is gone. Every particle is squished so close together that the star's density becomes almost unimaginable. Now, here's where things get even weirder. When a star collapses into a neutron star, it doesn't just sit there, it spins. And not just slowly either. Conservation of angular momentum, fancy term I know, means that as the star shrinks, it spins faster and faster. It's like a figure skater pulling in their arms during a spin to go faster. Some neutron stars spin hundreds of times per second. Yeah, you heard that right. Hundreds of times per second. These rapidly spinning neutron stars are known as pulsars. They emit beams of electromagnetic radiation, and as they spin, these beams sweep across space. From Earth, we see these beams as regular pulses of light or radio waves, which is how they got the name pulsar. Think of it like a cosmic lighthouse, except instead of guiding ships, it's giving us clues about the most extreme physics in the universe. As if spinning at hundreds of times per second wasn't enough, neutron stars also have some of the strongest magnetic fields in the universe. In fact, their magnetic fields can be trillions of times stronger than Earth's. To put that into perspective, if you had a magnet that strong on Earth, It would wipe out all your credit cards, mess with your electronics, and probably pull metallic objects right off the ground. But in space, these magnetic fields have even stranger effects. They twist and tangle, creating intense electromagnetic radiation. Some neutron stars, called magnetars, have magnetic fields so strong that they can release bursts of energy that are equal to billions of times the energy produced by our sun in just a fraction of a second. These bursts can cause incredible flares, and scientists are still trying to figure out what exactly causes them. Some think it's the result of starquakes. Yep, you heard that right. The crust of a neutron star can actually crack under the pressure, releasing enormous amounts of energy. So, what's inside these weird, spinning, super magnetic stars? Honestly, we don't really know. Neutron stars are so extreme that our current understanding of physics starts to break down when we try to explain what's going on inside them. We know that the outer layer is made up of a solid crust, but as we go deeper, the matter becomes denser and more mysterious. Some scientists think that deep inside, the neutrons break down into even smaller particles, like quarks. There's even a theory that the core of a neutron star might contain a type of matter called strange matter, which sounds like something straight out of science fiction. But the truth is, we're not really sure what's in there. Neutron stars are like natural laboratories for studying the limits of physics. And if you think neutron stars are wild on their own, just wait until you hear what happens when two of them collide. When two neutron stars orbit each other, they gradually get closer and closer together, pulled in by their immense gravity. Eventually, they crash together in a massive explosion called a kilonova. When this happens, the energy released is beyond anything we can imagine. It sends out powerful gravitational waves, ripples, in the fabric of space-time itself. These gravitational waves were first detected in 2017, and they've opened up a whole new way for us to study the universe. But that's not all. When neutron stars collide, they also create some of the heaviest elements in the universe, like gold and platinum. So the next time you look at a piece of gold jewelry, remember, it probably came from the collision of two neutron stars billions of years ago. The climax of this story comes down to one mind-bending fact. Neutron stars defy everything we know about the universe. Their density, their speed, their magnetic fields, and the strange matter inside them all point to the fact that we have so much more to learn. We've only just started to unlock their secrets. These stars are like cosmic time capsules, holding the answers to some of the most profound questions about the nature of matter, gravity, and the universe itself. And with new technology, like gravitational wave detectors, we're finally starting to glimpse what's going on with these stars. But here's the kicker, we're still scratching the surface. The universe has a lot more surprises in store for us. Neutron stars are one of the universe's greatest mysteries. Born from the explosive death of massive stars, they pack more mass into a tiny space than we can even begin to imagine. They spin faster, have stronger magnetic fields, and may even contain states of matter that we've never seen before. And when they collide, they literally shape the universe, creating elements and gravitational waves that ripple across space and time. We're only just beginning to understand these bizarre objects, but one thing is clear, neutron stars are far stranger than we ever thought. Hit subscribe, and let's keep exploring the universe together.